Hello wonderful person and welcome to Sagittarius A star. This is the central black hole in the middle of our galaxy and it's a relatively large and relatively massive object. But in today's video we're going to take a look at some other supermassive black holes, and as a matter of fact we're going to explore some of the largest supermassive black holes we've discovered to date and maybe even recreate it, or one of them at least, using Universe Sandbox Square. But in any case, enjoy this video and welcome to What the Math. And so what we're going to do first is we're going to take a look at the largest supermassive black hole available to us in Space Engine, which is unfortunately not the biggest out there, but nevertheless it's better than nothing. So we're going to go into the search box here and type APM. Now this is a galaxy called APM 082795255, but right in the middle of it is the central black hole that's also available in Space Engine. And so here we go, this is the galaxy APM 082795255, a galaxy that's about 12 billion light years away from us and is actually not very big. It's not a very large galaxy, but right in the middle there's a supermassive black hole that's a huge percentage of the total mass, and it creates a very interesting environment. Inside of this region right here, there is quite a lot of matter that actually falls into this black hole and creates a huge amount of energy. Now, unlike other quasars, this one, and this is actually a quasar because basically it projects a very, very bright sort of ray toward our planet Earth that we can see from really far away. But yeah, unlike other quasars, this one specifically doesn't have the relativistic jets that usually make it even brighter. But it does have a very large active nuclei region that produces a huge amount of energy. And as a matter of fact, this used to be one of the brightest objects in the universe until one of the other ones was found. But here specifically what's interesting about it is that we've also detected quite a lot of water from this region. As a matter of fact, there's so much water here that we think that this is probably the largest amount of water present in one spot in the universe. And so here we have something like 100 trillion times more water than on Earth. All of it is sort of in this central region. But the important finding here, of course, is that we now know that there was water basically from the beginning of the universe. So what we see from this galaxy is light that's about 12 billion years old. So even 12 billion years old, 12 billion years ago, there was water in the universe, meaning that maybe some of the water on Earth is actually a lot older than we can even imagine. But anyway, let's actually go to that actual black hole. We're going to zoom into it and take a look at it as well. So in Space Engine, this black hole has quite a lot of various stars orbiting around it. You can display them by pressing this button right here. And it's a very, very massive object. It's a huge object. It's a lot bigger than the Sagittarius A star in the center of our own galaxy. And here, basically, the mass is something like 23 billion masses of the Sun, which is in comparison to 4.3 million in Sagittarius A, which is our own supermassive black hole, is a tremendously large amount. So this is a super ultra massive black hole that creates a lot of energy and also absorbs a lot of mass so that this energy can be created. Now we're going to accelerate time here a little bit just so you can see what it looks like when the accretion disk spins. And you'll get to actually enter this particular supermassive black hole as well. And so here we go, and boom, we're gone forever. Now let's actually look at some of these stars that are orbiting around this supermassive black hole as well. I'm going to accelerate time just to show you that some of them only take, I think it's actually less than a year orbit. As a matter of fact, here, the one orbit is about 314 days, and that's very, very little compared to one of the stars that orbits around our own black hole, which usually takes about 16 years, and that's the closest star. But if we move a little bit farther away, you'll see that there's actually a lot more stars on the outskirts as well, and you can kind of accelerate time just to see what it all looks like in fast forward of about 10 or 20 years per second. So this is what the supermassive black hole does to all of these stars, and many of them lose matter that falls into this supermassive black hole to create all of the light that we can see from our planet Earth. Alright, so now let's escape this galaxy and leave this black hole, because I actually wanted to show you something really cool about this particular galaxy. Now, Space Engineer creates quasars relatively well, at least to some extent, when it comes to brightness. If you actually leave this galaxy and you move far enough away from it, the quasar effect kicks in, and you'll actually get to see the real brightness of this particular galaxy from a distance, or essentially what it would look like to us from Earth. So after 12 billion years, this light has reached us and kind of looked like this. And this is absolutely incredible. So this is the galaxy we just came from, but it is now displayed as a very, very bright quasar, which is essentially what it really is. It's a very, very luminous object, and even if you move away, far, far away from it, you'll still be able to see it. You don't even see these other galaxies, but you still see the quasar, known as APM 082795255. And I'll actually have to move away quite far away for me not to see it anymore. I can see it even from 1 billion light years away. And you can't even see our galaxies that far away. And let's wait until it actually finally disappears, because I actually want to see what distance I have to be at for me not to see it anymore. And 3 billion light years away from it, we can still kind of see a little spot in the middle. There's actually another one right there. That's another quasar. And I think right about here, maybe 4.3 billion light years away, that's when you can barely make it out. It's barely visible. But that's essentially how quasars are, how bright they are, and how we can actually see them from our planet Earth. Now, in the beginning I mentioned that this was 12 billion light years away. That's, of course, it's a mistake. The light has traveled for 12 billion light years, but in reality, because this quasar has always been moving away from our planet and from our star system, it's actually much farther away by now. In reality, this object is now something like 23 billion light years away, and we'll never ever be able to see what it really looks like now. And anyway, in this part I just wanted to show you this particular galaxy, but in the next part, which will be out tomorrow, I'm going to try to recreate another really beautiful object, another quasar, that is actually the most massive black hole in the universe that we found to date, using Universe Sandbox 2. Thank you so much for watching, and if you still haven't subscribed, please click the subscribe button right now, because there's so many more videos coming in the future. I'll see you guys in the next video, and here's another quasar for you to look at. This one is actually procedurally generated. Game you later, and as always, bye bye.